Hello students, we are doing the chapter 5 combustion and fossil fuels. Our next topic is extinguishing fire. So fire can be extinguished by controlling any one of the following conditions. Either you can add water or you can add sand to it. But water being uncombustible, non-combustible, decreases the ignition temperature of the burning material by absorbing the heat generated by the fire, thus lowering the temperature. But we cannot use the water in all the conditions. We cannot use the water when electric fires are there, because it is a good conductor of electricity. So water should not put on the fire caused by and water we cannot also use use to put off out the fires caused by petrol and kerosene or diesel, because they are lighter than water and they will float on the water. In such cases we use carbon dioxide as fire extinguishers. Carbon dioxide is mainly used as the fire extinguishers as it is not combustible. Okay, so we can put off the fire. Since it is heavier than air, it restricts the supply of oxygen, forming a layer between the fuel and oxygen. So carbon dioxide fire extinguishers are used as they do not damage the electrical equipments. The two commonly used fire extinguishers are carbon dioxide fire extinguishers and soda fire extinguishers. Carbon dioxide fire extinguishers contains carbon dioxide filled under high pressure in cylinder. We fill the carbon dioxide under high pressure. Okay. This fire extinguishers cool down the combustible substances besides cutting off the supply of air. Similarly, soda fire extinguishers, they are generally filled in this. They are filled with the concentrated solution of sulfuric acid and sodium hydrogen carbonate. When they both mix together, they form carbon dioxide. This carbon dioxide will help in extinguishing the fire. So these are the two types used for the fire extinguishers. And now the next is sand. Sand can also be used to extinguish the fire, as it cut off the supply of oxygen by forming a blanket over the burning substance. Next, flame. Okay, in this activity we take water and sand. Okay, in this water what we do, we take a tray. In a tray we cut the pieces of paper and just put it and burn the paper. Now try to extinguish the fire by putting the water and sand. So if we put sand and water, both the fire get extinguishes. Okay, so next, this is flame. The region in which the combustible fuel takes the place is called as flame. The color of the flame depends upon these parameters: nature of substance that is burning, amount of air, and temperature. Blue flame is also referred as non-luminous flame, as the complete combustion takes place in the zone by emitting very little light, whereas yellow flame is referred as luminous flame, as incomplete combustion takes place in this zone. Okay, now the structure of candle. In the structure of candle, we divide the flame into three parts. One is outer zone, which is called as blue and non-luminous zone. It is the hottest part of the flame, where the complete combustion takes place due to the availability of maximum amount of oxygen. The second part is yellow or non-luminous zone. It is moderately hot zone as compared to the outer zone. Okay, in this, incomplete combustion takes place because the oxygen supply is less. So this is an incomplete combustion. In this, incomplete combustion takes place, which results in the formation of unburned particles, that is called as soot. Next, inner zone. The inner zone is the dark zone, or which is dark zone, or we can also call it as black zone. It is the coolest part of the flame. In this zone there is no supply of oxygen, so the wax vapor remains unburned here. This zone does not emit any light. It is dark in color, that is black in color. It covers the unburned vapors, producing the melting of wax around that area. Okay, at the base of the wick there is a small blue colored region in which the carbon monoxide is burned. So when you will see at the base, you will see a blue color region in which the carbon monoxide is burned. Next, combustion of a wax candle. A candle is composed of two main parts: paraffin wax that acts as a fuel, and the wick that can absorb water or the molten wax. When you observe a candle, you may notice that the wick is burning, but actually the wax vapor also burns along with the wick. So now neither the solid wax nor the liquid wax will burn. It is the wax vapors that burns. Okay, whenever you see in the candle, only the wax vapors are burning, nor the solid wax nor the liquid wax. When we light the candle, the wick, the heat released from the flame melt the wax around the wick. Okay, due to the heat, the wax which is present around the wick, it gets melt up. The wick absorbs the molten wax, and heat produced from the flame vaporizes the molten wax in the wick. The wax vapor then burns the flame, and this process continues until the entire candle is extinguished. Okay, next, state the following statement as true or false. The substance that starts burning below the ignition temperature? No, this is false. Burning of sodium is an example of complete combustion. This is false because it is an example of spontaneous combustion. A blue flame is a luminous flame? No, it is a non-luminous flame. Complete combustion occurs in the outer zone of the flame? Yes, complete combustion occurs on the outer zone of the flame. Next, fuel. The substance that produces light and heat when they are burned are called as fuel. Example: wood, coal, kerosene, cow dung cakes, etc. LPG, petrol, etc. See, these fuels are divided into three types: solid fuels, liquid fuels, and gaseous fuels. Solid fuels are the fuels that exist in the solid state at room temperature. Liquid fuels are the fuels which exist in the liquid state, and gaseous fuels are the fuels which exist in the gaseous state at room temperature. Example of solid fuels, you know that: coal, wood, dung cakes, agriculture waste. Liquid fuels: LPG, kerosene, petrol, diesel, whereas gaseous fuel is petroleum gas, biogas, coal gas, etc. Now, calorific value. Calorific value is the amount of heat released when 1 kilogram of fuel is completely burned. Okay, when you burn 1 kilograms of fuel, the heat which is released is called as calorific value. The units of calorific value is kilojoules per grams. If the calorific value of the substance is high, then it is an efficient fuel. So, calorific values are given in the table. Next, characteristics of good fuel. What are the characteristics of good fuel? Good fuels are it should have the characteristics. These characteristics. First, low ignition temperature. The temperature, its ignition temperature should be low below, but above the room temperature. It should have high calorific value, moderate rate of combustion. It should not cause any pollution. It should be available easily. It should not be expensive. It should be safe to handle, store, and easy to transport. No residue. There should be no residue left after burning. These are the characteristics of a good fuel. It's important you have to learn these characteristics. Then, commonly used fuels. LPG and methane gas are most widely used domestic fuel. They do not lead to any pollution. Diesel and petrols are widely used in the automobiles, but the availability is very less, and they also leads to the atmospheric pollution. Now, hydrogen as a fuel. Hydrogen has the highest calorific value, but it is considered as the best fuel as it is highly inflammable and it is difficult to handle, transport, and store. It is used as a rocket fuel. Next, fossil fuels. The fossil fuels are formed from the buried remains of animals and plants over a long period of time, like millions of years. These are also referred as natural resources. They are obtained from the nature. Petrol, coal, and natural gas are the examples of the fossil fuels. First, we are going to discuss about the coal. Coal is a black colored hard fossil fuel. There are different varieties of coal based upon the carbon content. The first is anthracite. I have discussed in the session also. Anthracite, it has the highest percent carbon content, that is 90 to 96%. So it is used in the domestic fuel because it does not give out much smoke, and it is best variety of coal. Bituminous coal, it has the carbon content of 65 to 80. It is used for power generation. Subbituminous coal, it has the carbon content nearly 30 to 35, and it has the low heat value. It is used because it is burns without giving much smoke. Lignite contains low amount of carbon, that is 25 to 35%, and came into existence in very recent period. It is used for in the power generation, and it is the lowest grade of coal. Next, peat. Okay. Peat is the material formed from the coalification processing consisting of partially decayed matter deposited mineral. Peat is formed in the wetland. It has low carbon content and high moisture content, so its heating capacity is low. Next, formation of coal. How the coals are formed. The dead remains of plants and animals get deposited deep inside the earth for over millions of years. Then, due to high pressure and heat, the high pressure combined with the heat forms the interior surface, which changes into organic matter. First, this organic matter changes into peat, then it takes millions of years to convert into the different types of coal. The coal depends upon the time, pressure and temperature. A good quality of coal is subjected to high temperature and pressure. Next, uses of coal. Coal has many different uses. It is used in the Industrial Revolution. It is used in power generation, steel production, extraction of coal and cement manufacturing. The different countries' largest coal users of the world are China, USA, India, Russia and Japan. Next, products which are obtained from the coal. There are three products which are obtained from the coal, that is coke, coal tar and coal gas. Coal is a tough, porous and grey colored substance obtained from the bituminous coke. Okay, it has high temperature fuel and is the major source of energy. Coal tar is black in color, black liquid or brown liquid with the unpleasant smell, and it is one of the byproduct when coal is used to make a coal. When we make the coke from the coal, it is a byproduct, that is a waste product, you can also call it as. Next, coal gas. Coal gas is also the byproduct formed by the processing of coal into coke. Okay, it is used as a fuel for the stoves and fireplaces, but nowadays this coal gas has been completely replaced by electricity. Now similarly, petroleum, or we can also call it as crude oil. It is trapped in the underground rocks and it is used as a fuel. Formation of petroleum. How the petroleums are formed? See the formation, see the figure. Petroleum and natural gases were formed over the million of years from the organisms that lived in the seas, that is aquatic plants and aquatic animals. These organisms die. When these aquatic plants and animals die, they get buried under the bottom of the seabeds and covered with the sand and clay layers. Due to the absence of air and high temperature and high pressure, they get transformed into crude oil or the petroleum and natural gas. Now the crude oil is taken out, and now the next step is to refine the petroleum. Petroleum is a mixture of solid, liquid and gas hydrocarbons. The process of separation of various constituents into the substance is called as refining. It is done in the petroleum refinery. In this, first the crude oil is heated at high temperature around 400 degrees centigrade. Okay, the crude oil is taken in a heater and it is heated. From the heater, it is passed into a fractionating column that it contains horizontal trays. See, when it is heated, it changes into vapor and it passed into fractionating column, where it condenses. Vapors condenses in the fractionating column at various heights and get collected in the trays. The condensation of the substance depends upon their boiling point. The uncondensed hydrocarbons are released out of the column. The various components with different boiling points are referred as fractions. Therefore, refining process is also called as fractional distillation. Next, from the petroleum, the products obtained from the petroleum, that is petroleum gas, petrol, kerosene, diesel, fuel oil, lubricant oil, paraffin wax, bitumen. Okay, and their uses are given in the table. Like petroleum gas, that is LPG, it is used in the domestic fuels. Petrol, it is used in the automobiles, aviation fuels and dry cleaning. Kerosene, it is used in the lamps, stoves and jet engine. Diesels is used as the fuel generators and heavy motors. Fuel oil, it is used in the ships and power station. Lubricant oil is used in the machinery. Paraffin wax, it is used in ointments, vaccine, candles, etc. And bitumen, it is used in the paints and building of road. So I am stopping my topic till here. The next topic we will continue in the next session. Thank you.